By the end of this video, you'll be able to identify prime numbers and composite numbers clearly from the number line. And you will learn 3 common tips often seen in the exam. To understand prime numbers and composite numbers, let's consider the number line. 0 is a neutral point. We count from 1 towards the positive infinity, which is usually represented as plus x or plus infinity on the number line. All the numbers from 1 to infinity are simply known as positive numbers or natural numbers or counting numbers or non-negative integers or positive integers. But if we decide to count from 0 and we move towards the positive infinity, just the inclusion of 0 will change all these names to become whole numbers. In addition, if you count from -1 and we move towards the negative infinity, which is also minus x as is, all the numbers from -1 towards the negative infinity are simply called negative numbers or negative integers. This is the first step in the analysis of the number line. Also recall, if we divide all these numbers, each of them by 2, any integer on the number line that returns a whole number after dividing by 2 will be called an even number, and any integer divided by 2 which returns a fraction or a decimal will be called an odd number. Once you have understood all this, what then are prime numbers and what are composite numbers? A prime number will only divide itself and 1. That means prime numbers can only perform 2 actions, not 1, not 3 actions or more. Prime numbers can only perform 2 actions. When an integer can perform only 1 action or 3 or more actions, they are simply called composite numbers. Prime numbers and composite numbers considers only from 1 to infinity, which can be called positive numbers or natural numbers or counting numbers or non-negative integers or positive integers. Prime numbers and composite numbers do not consider 0. In addition, they do not consider all the negative parts of the number line. The consideration starts from 1 towards the positive infinity. Next, let's identify all the prime numbers and composite numbers from 1 to 20. Let's identify prime numbers and composite numbers from 1 to 20. 1 is the starting position. Integers less than 1 will not be considered. The first positive number is 1. That is, the first counting number is 1, which is also the first natural number. We are going to test if 1 is a prime number or a composite number. A prime number will divide only itself and 1. Here, 1 divided by 1 will return an integer. Only 1 action has been performed here. And to be classified as a prime number, you need to perform more than 1 action. And 3 actions will not be allowed, just only 2. But only 1 action was performed here on 1. 1 is not a prime number. 1 is a composite number. If you are not prime, then you are composite. Next, let's test for 2. 2 will divide 2. The division will return an integer. Likewise, 2 divided by 1 will return 2. Because 2 actions have been performed, 2 is classified as a prime number, not a composite number. The reason 1 is not a prime number is that it can perform action on itself and nothing more. 2 can perform action on itself and on 1. Remember, this is the boundary and nothing goes beyond these points. Next, let's test 3. If 3 is a prime number or a composite number, we are going to divide 3 with 2 and 1. 3 will divide itself. We are going to have 1. 3 will divide 2. We are going to have a fraction. Hence, we ignore. 3 divided by 1 will return an integer. 2 actions were performed to return an integer. And for a number to be classified as a prime number, you can observe that only 2 actions were performed to return an integer. If it returns fraction or decimal, we are going to ignore it. The number 3 satisfies the requirement. That means 3 is classified as a prime number. Let's quickly test for 4, which will divide 3, 2, and 1, and 5, which will divide 4, 3, 2, and 1. If you test 11, it will divide 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. If you test for 81, it will divide everything below it up till 1. This is the characteristics of identifying a prime number or a composite number. Let's consider 4. 4 will return 1 when it divides 4. When 4 divides 2, it will return 2. When 4 divides 1, it will return 4. You see, 3 actions have been performed to return an integer. We are going to ignore the fraction. You can see when we consider 4 as an integer, it has violated the definition of a prime number itself and 1 only. And 4 will be grouped in composite numbers. Next, let's consider 5. 5 will return 1 when it divides itself. If 5 divided by 1, it will return 5. Any other number below it, it will return a fraction, which we are going to ignore. 5 satisfies the requirements of a prime number, dividing only itself and 1. 5 is a prime number. Next, consider 6. 6 divided by 6 will return 1. And 6 divided by 1 will return 6. However, in between, 6 will divide 3 to return 2. And 6 will divide 2 to return 3. Now we have a lot already, more than 2. This is a fraction and this is also a fraction. 6 has performed 4 actions and has violated the definition of a prime number. 6 is a composite number. Next, 7 divided by 7 will return 1. 7 divided by 1 will return 7. And in between, everything is a fraction. 7 satisfies a prime number definition. And 7 will be inside the prime number group. Next, 8 divided by 8 will return 1. 8 divided by 1 will return 8. And in between, 8 will return 4 when it divides 2. 8 will return 2 if it divides 4. Every other thing is a fraction. However, 4 actions have been performed. 8 is not a prime number. 9 divided by 9 will return 1. 9 divided by 1 will return 9. In between, 9 will divide 3 to return 3. In between, we have other fractions which we are going to ignore. 3 actions have been performed. 9 is not a prime number. 10 divided by 1 is 10, and 10 divided by 10 is 1. In between, we have 10 divided by 5 as 2, 10 divided by 2 as 5. Though we have fractions, but 10 have performed 4 actions. 10 is not a prime number. Next, 11 divided by 11 is 1, and 11 divided by 1 is 11. In between 1 and 11, every other division is a fraction. 11 is considered as a prime number. Let's consider 12. 12 divided by 12 is 1. 12 divided by 1 is 12. In between 1 and 12, we have 12 divided by 4 will return 3, and 12 divided by 3 will return 4. We have 2 additional divisions which returned an integer. 12 divided by 6 will return 2. 12 divided by 2 will return 6. Every other division will return a fraction. However, 12 have performed 1, 2, 3, 4, 5, 6 actions. 12 is not a prime number. 12 is a composite number. Here we have the first group of prime numbers and composite numbers from 1 to 12. And if we consider from 13 up to 20, 13 performed 2 actions, which is a prime number. 14 performed 3 actions that returned an integer. 14 is a composite number. 15 performed 4 actions that returned integers. 15 is not a prime number. 15 is a composite number. 16 is not a prime number. 17 performed only 2 actions that returned integers, which satisfies the definition of a prime number. 18 performed 5 actions, which is a composite number. 19 performed 2 actions, which makes it a prime number. 20 here performed 6 actions that returned integers. 20 is a composite number. We have successfully identified all the prime numbers and composite numbers from 1 to 20. You can continue with this identification from 1 to 100, shading out all the prime numbers by using any color pencil of your choice. The shaded squares here are all prime numbers from 1 to 100, and the remaining numbers are composite numbers. You can also pull out and separate all the prime numbers and put them together. These are the first prime numbers from 1 to 100. Now you can identify prime numbers and composite numbers using this definition. In addition, these three tips are very common in the exam when dealing with prime numbers. The first consideration is that 2 is the only even number that is a prime number. Recall that when you divide any number by 2 and it returns an integer, it is called an even number. In all the shaded portions, if you pull them out, separated and grouped together, 2 divided by 2, 3 divided by 2, 5 divided by 2, 7 divided by 2. If you divide all these prime numbers by 2 up to 97, the only number that will return an integer will be 2, which is 2 divided by 2 is 1. Every other prime number here will return a fraction or a decimal. This is a very important concept to remember in mathematics, that 2 is the only even number that is a prime number. This is a very important exam question. Next, the second exam tip is the first 4 prime numbers are 2, 3, 5, and 7. Considering from 1 to 100, all the yellow shaded numbers are prime numbers. The first 4 prime numbers are 2, 3, 5, and 7. Also, the first 8 prime numbers are 2, 3, 5, 7, 11, 13, 17, and 19. In addition, the first 10 prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23, and 29. But the most common in the exam is the first 4 prime numbers. And you should also try to identify the first 4 composite numbers. In the third exam tip, all prime numbers above 5 end in 1, 3, 7, or 9. Consider all the prime numbers from 1 to 100. You can observe that the shaded numbers are prime numbers. All the prime numbers above 5 ended in 1, 3, 7, or 9. You can observe that there are some exceptions. That means not all the numbers that ended in 1, 3, 7, or 9 are prime numbers. But how can we identify those numbers? We use 3 and 7 to divide each of them. Let's consider all the prime numbers that ended in 1. If you use 3 or 7 to divide 11, 31, 41, 61, and 71, none will return an integer. All will stay being fractions. But if you use 3 or 7 to divide 21, 51, 81, or 91, either 3 or 7 will surely return an integer. For example, 21 divided by 3 will return 7. 21 divided by 7 will return 3. 51 divided by 7 will stay a fraction, but 51 divided by 3 will return 17. Because one of them returned an integer, 51 is not a prime number. If you test 81 divided by 7, it will stay a fraction. But if you divide 81 by 3, it will return 27. Because it returned a whole number, 81 is considered not to be a prime number. 91 divided by 7 will return 13. But 91 divided by 3 will stay a fraction. Because 7 tested and was successful, 91 is not a prime number. You can use 7 and 3 to test all the numbers that ended in 3, in 7, and in 9. If any returns an integer, either by 3 or by 7, then that is not considered as a prime number. This is one way we test prime numbers from 1 to 120. When the number is above 120, the 3 and 7 tests might not work. These 3 tips are very important to all exam questions relating to prime numbers and composite numbers. In addition to identifying prime numbers and composite numbers, I will recommend watching these other video topics and these ones too, to help you clear all the confusions in numbers and arithmetic, classification of numbers, and the analysis of the number line. I have left all the video links in the description and in the comment section. I hope this video was helpful.